Good afternoon, everybody. Um, Hope you're doing very well. As mentioned in the email and in the class modules, we are going to have our second exam on Thursday, April 29, and today is going to be our review for the second exam. This is a comprehensive exam. This is going to include the material for that we have discussed for the entire semester. And the reason it is cumulative, it is because everything that we have discussed is a building block to the next part of the class. So basically, even if I ask you to study the second half of the class, you'll still gonna have to work with the material that we covered in the first semester, the first part of the semester. So it's a cumulative exam. We're gonna include questions that will touch on topics for the entire semester. That is, and that's what we have listed as part of the review. As always, the exams, at least for this class, have two parts. The first part is going to be a 10 questions that could be multiple choice or true or false questions. And these questions are going to have a total value of 2 points. So 10 questions, 2 points each. That's going to be a total of 20 points for your exam. And then section number 2, you will have 3 to 4 topical problems, short answer, explanation, description of mathematical questions. So in this part of the exam, I'm going to ask you, for example, to draw some UML diagrams for a specific situation. I can also ask you to list, like we did in the first exam, some of the important concepts. So I believe in the first exam, I asked you to list the steps for the system lifecycle model. So that's still a very important concept. So you should remember those steps. And also we have causal loop models, we have n-squared charts. So obviously, I'm going to design the exam for 1 hour and 20 minutes. So I'm going to be careful in terms of what diagrams you'll be able to draw during the time period designed for the exam. Also, we have some questions similar to the ones that we have in the homework. Like, for example, I can ask you to complete a experimental table in which I give you the inputs, and you can list the state changes, and like we did for one of the homeworks, and actually for one of the bonus that we have for the exam. So that type of question could be also something that you will see in the exam. But in general, go back to look at the assignments. I know some of you are struggling with assignment number 8. So some of those questions require some thinking and time. So if I ask you something along those lines, it's not going to be that difficult. It will be obviously more simple because you have a limited time for the exam. So in that assignment, in assignment 8, you have a combination of concepts. You have to know how to draw a state transition diagram based on the inputs, how states are changing, and then using that information, the inputs, the state changes, and the outputs of your system, you design a discrete event mathematical model that is going to define mathematically what are the inputs, what are the outputs, what are the state transitions, based on the dynamics that you observe in your system. So assignment 8 also is asking you to draw some UML diagrams. So that's important. So you go and do some of that for preparation for this exam. So I got a couple of emails asking me about extending the time for submitting assignment 8. So I sent an email this afternoon extending the time for submission. So you have until tonight at 11:59 p.m. to submit that assignment. So if you submitted already and you don't feel comfortable with the submission, you can still revise your answers. But if you haven't submitted yet, you have until tonight. The reason I'm not letting you submit tomorrow is because I need to post the solution for the assignment. So if I believe it will be better for you to see the solution, let's say tomorrow morning. You have the entire day to study that assignment solution. So that's why I'm not going further than tonight for submission. So let's go through the material that we have covered this semester. So again, these are the bullet points that were listed at the beginning of each one of these lectures. So we started with introduction to systems engineering. So here we define what systems engineering is. So that's something that you need to know at this point. The examples, what type of systems require systems engineering, and so on. System thinking, so you need to know what system thinking is. You need to understand what are the fundamental system construct and the system principles. In terms of lecture number 3, the structure of complex systems, understand what the system development process is, the hierarchy of complex systems. So we went through that hierarchy multiple times during the semester. What are systems? What is systems of systems? What is the system environment, and why it's important for you to understand what the system environment and how that affect your design. And also the importance about interfaces and interactions. Then from there, we move to the system development process. So the system lifecycle model, as I mentioned already, is very important. The systems engineering method and how they are connected. So the systems engineering through the system lifecycle. In terms of the theory of system design, we talk about the system design requirements and the differences between a functional system design, a buildable system design, and an implementable system design. So there's some type of requirements that are associated with each type of design, from functional to buildable to implementable. So understanding the differences between those 3 types of systems and the type of requirements that needs to be formulated for each one of those is also important. So writing system requirements, this is part 4 of lecture 4. I wanted to highlight this one because there was some, when I graded the second part of, or the progress report for the project, there's still some students that are not aware that there's some specific, there's a specific way for writing requirements. So if you don't remember that, that's very important. You should go through this lecture, make sure that you understand how to write system requirements. That's is going to be relevant for this exam, and also it's going to be relevant for the final report of your project. So make sure that you follow the guidelines discussed in this lecture, writing requirements, the type of requirements, writing good requirements, and also common problems in writing requirements. In terms of part 5, I will say that this is not going to be material that I'm going to be testing in the exam. Part 5 is important mostly for your final project report. So part 5, it's important that you go through this lecture, that you understand the material in this lecture, but that's going to be mostly, well, it's going to be tested in the final report. So it's not going to be part of what I'm going to be testing in the exam. So part 5 of lecture 4 is relevant for your final project, but I'm not going to be asking questions from this section because I know you're going to be looking at this lecture in detail when writing your final report. Part 6 is systems engineering task. Then we transition to the different stages of the system lifecycle model. So we spent some time looking at the first 3 stages of the system lifecycle model. And we started with the needs analysis. So part 1 is need analysis, understanding the originating a new system, operations analysis, function analysis, feasibility definition, needs validation. So all these concepts that are associated with the definition of the needs or the definition of the need for your system. Some of the concepts that are discussed in this lecture are tied to the material that we cover here in the theory of system design. So you will see that there's some things that are in common. So in this part of the course, we were focusing on defining the need for a system. And we also talk about the concept exploration, which is the second stage. So developing the system requirements, operational requirements analysis, performance requirements formulation. We also talk about the set theory. So we spent some time looking at how to define sets and how to use those to define mathematically the models for our systems. So this set theory lecture discussed some mathematical concepts that if you see the next lecture that follows this material, it's relevant for you to understand how to define the discrete type of systems models, which is what we do in part 4, discrete time system models. So I know some of you were familiar with these concepts. I still wanted to give you that review because those are relevant for what you see next, which is the system models, what is modeling models for systems engineering, and the concept of dynamical systems, and also the discrete time system models. So here's where we go through the state transition diagrams, the input state and the output trajectories. And this is the material that you are you're working with in terms of assignment 8. So how to design a model, a discrete time system model for the situation that is stated in the assignment. And system experiments. So I believe the bonus assignment that I gave you is connected to the system experiment. So how to use, if you have a list of inputs given an initial state, how your system will behave based on that information. So you had a table, you have the state changes, you have the inputs. So based on those inputs, you were stating the changes, and also based on the state changes, you will stating the outputs for your system. We also talk about performance indices for your system. And then finally, we talk about the last or the third stage of the system lifecycle model, which is the concept definition. So how do you go from a concept from the need analysis to concept exploration, and then to concept definition. So selecting the system concept, performance requirement analysis, functional analysis, and formulation, then concept selection, and the unified modeling language, which is useful to see some of the behaviors of the concept, of the system concept that you have proposed. And then I gave you an introduction to the unified modeling language in part one of concept definition. And then we have an additional lecture on how to build those diagrams. So for the exam, I mean, those class diagrams, the state transition diagrams, the sequence diagrams, those are going to be important. So you need to know how those diagrams are developed. And if I give you a specific situation and I ask you to draw a sequence diagram, you should know what are the components of a sequence diagram and how to draw a simple sequence diagram for that situation, or a class diagram for that situation, or a state transition diagram for that situation. And also the use case diagrams are also relevant. So at least have a good understanding about those four: the UML diagrams, the use case diagrams, sequence diagram, state transition diagram, and the class diagrams. Those are relevant. So that's in terms of the material for the exam. In terms of preparation for the exam, I always recommend to go and check the textbook. So we cover chapters 1 through 8 of the textbook for this class. The material, not all the material that we cover in class is in the textbook, but the majority of the lectures are based on the textbook material. So my advice always to prepare for the exam is to go over the lecture slides, which are posted in the modules, and also to look at the assignments and the solutions. The exam is closed book and notes. And as always, or as we did for the first exam, you're gonna have a link to access the exam in Canvas. So there's gonna be a module available on Thursday, and you're gonna have it's gonna be open at 3:30, and you are going to access the exam using that link. Clearly show your work and all formulas used in your solution. So I'll provide with partial credit if you show me your work and the solution is not completely right, I will provide you with partial credit or most of the credit, but you have to show me the thinking process and how you come up with your solution. Multiple choice true or false questions will be answered with the computer in the computer, so you will be selecting the answer. But for the questions and the problems, you're gonna have to upload a file. So my advice is to work the solution in a piece of paper and then take a picture or scan and upload your solution file. I'll give you 15 minutes to upload your files. So the exam will start at 3:30. So at 5 p.m., you should stop working with your exam. And then you have until 5:15 to upload the files associated with the problems that you, or your answers for the problems. So you'll have 15 minutes to upload those files to Canvas. So I guess that's my last slide in terms of the review, and I now have time to answer questions. If you don't feel comfortable asking questions, you can always send me an email, but I think someone was gonna ask me something,
Yes,
so
sir,
go
I have
ahead.
a question. Like you told that in part B, we'll be having questions like 3 to 4 questions where we should actually scan and upload a file. So in that case, it will be only scanning and uploading, or will there be any questions where we should just type answers like the true or false, like the multiple choice?
Okay, so that's a good question. So um, if I haven't designed the exam yet, but if in the case that there's a question in which you need to write just words, you can also write it in a piece of paper and then take a picture and upload that. So that would be my advice. So
Okay,
it,
so you mean that there'll be a upload section available for that question too, right?
yes, yes,
Yeah, all
yes.
right, thank you. Yeah.
Any other question? Okay, so if you have questions, you can email me. I'll be available tonight. I mean, I have another class this afternoon, but typically connect around 10 p.m. again to check my email and answer questions. So if you have questions, I'll be able to answer those tonight. And tomorrow I should be available also if you have any questions. So feel free to email me and I'll get back to you. If there's no other questions, then I'll stop the session now and I will post, I mean, I will see you on Thursday. Bye bye.